This is 5.8 quadratic modeling, part 1. We are going to be doing one problem in this lesson. I am warning you that it is a long problem. What we also call in math quadratic modeling is quadratic regression. So here's the example. What they give us is 3 ordered pairs. These 3 ordered pairs fall on a quadratic function. Remember, a quadratic function is a parabola. So these 3 points, if I say this parabola opens up, they're going to fall on this parabola. What we want to do is come up with what would be the equation of this function. So these are my 3 ordered pairs. And I'll give you a little bit of time to write up the problem. And then below on this slide is I have a little chart where we'll find a system. We'll be referring back to chapter 3 where we are solving systems of equations with 3 unknowns. So think back to linear programming where we had x, y's, and z's. So what we're going to start off with is 3 ordered pairs. And we want to come up with what the 3 equations will be in a system with A, B, and C. So the first column is going to be the ordered pairs. The second column is what we plug in to the equation y equals ax squared plus bx plus c. And the third column is going to be our system equations. All right, so we're going to go to filling in this chart. So let's start off with the first ordered pair. The first ordered pair is 1, -5. The 1 represents the x, and the -5 represents the y. And we are going to be substituting in y of -5 and x, which is 1. And then we're going to reduce it down to an equation that's in A, B, and C form. Let's go ahead and substitute in. So our y value of our ordered pair is -5. Our x value is 1. So we're substituting in 1 in for x. So here's what our equation looks like when we substitute this ordered pair in for x and y. Now we're just going to reduce it down a little bit. So we have -5, then 1 times 1 is 1. And now I'm just going to drop those 1s because 1 times a is a and 1 times b is b. Now over here, I'm just going to write the equation a plus b plus c equals -5. All right, let's go down to the second box set. That's the next ordered pair they gave us in the problem that's on the parabola. So we're going to substitute in 3 and 5 into a general quadratic equation. So this is my x and that is my y. So I'm substituting in 5 in for y, 3 in for x. Now I reduce it down. 3 times 3 is 9. And now 9 times a is 9a. 3 times b is 3b. And I'm just going to finish off this column in standard form. So I have 9a plus 3b plus C equals 5. And I have one more left, the 0.416. This is my x value, and this is my y value, and I substitute it in one last time. So my y value is 16, my x value is 4, I should say a there, 4 squared plus b times 4, and then plus c. Now let's reduce it. 4 times 4 is 16. And then 16 times a is 16a. And then 4 times b is 4b. Now let's write in the same order. 16a plus 4b plus c equals 16. Now I'm going to work with these three equations on the third column. So I'm going to work with this one, and this one. And what I have is a system of three equations with three unknowns. So on this next slide, I've just rewritten the three equations as a system. So these three equations are from the last slide, third column. I'm just going to call this equation 1, equation 2, and equation 3. These were from my ordered pairs that were given to me. And what I have to do is I have to go out and find out what is the value of A, what is the value of B, and what is the value of C in this system. So I'm going to use elimination method like we did in chapter 3. And we'll take this problem nice and slow. I'll tell you what the steps are for solving for A, B, and C. So step 1, we're going to work with equation 1 and equation 2 in this system. And we're going to try to eliminate one of the variables. Well, it makes sense if I look at this set of two equations, it's probably best to eliminate the C. So I'm going to multiply one of the equations by a -1. So I'll just change this one by multiplying it to -1. So I have -1a, -1b, -1c equals now a +5. I'm going to add it to 9a plus 3b plus c equals 5. Now let's add. -1a plus 9a is 8a. -1b plus 3b is 2b. And then -1c plus c cancels out, and that's what we wanted to have happen. And then we have 5 plus 5 is 10. Step 2. Now we're going to work with equation 1 and 3 from our original system. And we want to eliminate the c again. So the equation 1 is a plus b plus c equals -5. And then equation 3 is 16a plus 4b plus c equals 16. So let's do the same thing again. We want to change one of the equations by multiplying it to -1, so our c's will cancel. So let's multiply this equation by -1 again. So I get -a, -b, -c equals, and now -1 times -5 is a +5. And I'm not going to do anything with that second equation. So I just add 16a plus 4b plus c equals 16. Now let's add. Negative a plus 16a is 15a. Negative b plus 4b is 3b. And then negative c plus c cancels out. They become 0, and that's what we wanted to have happen. And then 5 plus 16 is 21. Now what we're going to do on the next slide is we're going to work with this equation and this equation and try to eliminate either the a or the b next. I'm going to stop the recording there, and then we'll pick back up again.